is carbon chain. Second one is having a branch. How auntie and chutney are related? How auntie and chutney are related? Come on. A, functional isomers. B, position isomers. C, ring chain isomers. D,
Position isomer.
They are position isomers. It is one butene, it is two butene. They are position isomers. Notice, if there is a variation in the position of substituent or a functional group in the carbon chain, it is called position isomer. How auntie and donkey are related? Both have C4H8 formula. A, chain isomers. B, position isomers. C, ring chain isomers. D, functional isomers.
Functional isomer.
Now, they are called ring chain isomers. Alkene and a cycloalkane, both are differing. Only one is having a ring, one is having a open chain. One is having unsaturated carbon, one is not having. They are called ring chain isomers. Notice in cyclobutane, all carbons are sp3 hybridized. In butene, two carbons are sp2, two are sp3. So, ring chain isomers. Okay, sir? Are we very clear? Hello?
Yes, sir.
Sir. 1 chloropropane, 2 chloropropane. How they are related, sir? A and B are related as functional isomers, position isomers, chain isomers, and ring chain isomers. How they are related?
Position isomers.
Both they have continuous chain of 3 carbons. Both have same chain, but they are differing in the position of Cl, position isomers. Okay, sir. This is called ethoxyethane. This is called methoxypropane. The oxygen is a bivalent functional group that can be linked to carbon chains on both sides. Ethers, ketones, esters, secondary amines are compounds which are said to have bivalent functional group. For this functional group, either side you can have carbon chain. Now, if you look at this compound called ethoxyethane, its formula is C4H10O. If you look at the methoxypropane, its formula is also C4H10O. Now, they are differing in the nature of length of carbon chains linked to oxygen. Such pair of compounds which differ in the length of carbon chains linked
metamers.
to bivalent functional groups like ethers, ketones, esters, and secondary amines are called metamers. They are called metamers. Let us look at a question. There is a compound of formula C3H6Cl2. How many isomers it can have? This formula C3H6Cl2 indicates its degree of unsaturation is 0. I made a video on degree of unsaturation. Do you remember? If you don't remember, you watch the video. Watch the video. It indicates it is a saturated hydrocarbon. It is only a derivative of alkane. Anyway, it can have both Cls on carbon number 1, 1,1-dichloropropane. It can have one Cl on first carbon, one Cl on second carbon. It can have one Cl on first carbon, one Cl on third carbon. It can have both Cls on second carbon. So C3H6Cl2 can be 1,1-dichloropropane, 1,2-dichloropropane, 1,3-dichloropropane, 2,2-dichloropropane. How many isomers are possible? 4. Can you see it really? Hello?
Yes, sir.
This
Yes,
is a
sir.
complicated question. You ask a number of isomers, that becomes really difficult and challenging. For example, this is a IIT advanced question. Sir, very sorry, sir. Many people cannot understand it. If they can't understand, they should leave this. There is no way. Really, there is no way. I can't explain because you should try. If you ask me why A is like this, B is like this, C is like this, D is like this, explain means nobody can explain. This is the way ABCD exists. Only by observation we have to remember. Sorry, please tell me, explain, sir, why X is like this, why X is not like this. Come on, you explain means what can I do? Can I do anything, sir? Hello?
No.
I can't really do anything. Though I want to do something, I can't do anything. So this requires practice. If I'm given a structure like C3H6Cl2, I should see the degree of unsaturation and its degree of unsaturation is 0. It means it is like alkane. In alkane, 2 Cls have come. So C3H6Cl2 propane with 2 chloro groups. I can arrange the 2 chloro groups in how many ways I will see. I can put both chloro on the first carbon. I can put 1 chloro on first carbon, 1 chloro on second carbon. 1 on 1, 1 on 3. Or I can put both on second. Only there are 4 ways to arrange. So there can be 4 dichloropropane. Question will become really complicated. If it is C4H8Cl2, how many compounds exist? Again, this formula indicates it is a saturated compound. All are single bonds. Luckily, you should know whether there are any possible double bonds. Degree of unsaturation is 0. Degree of unsaturation is 0, only saturated. Now I can think, I can write 4 carbons in a straight chain. I can write 4 carbons with a branch. Now I see, I can put both Cls on carbon 1. I can keep on varying. I can put both Cls on carbon 2. I can put 1 Cl here, 1 Cl here. 1 Cl here, 1 Cl here. 1 Cl here, 1 Cl here. So how many possibilities I wrote so far? 1, 2, 3, 4, 5 possibilities. Now here, if it is having a branch like this, I can put both Cls here, one possibility. Whether I write here or here or here, no difference. What is the other possibility? I can put 1 Cl here, 1 Cl here. Yes, sir? I can put 1 Cl here, 1 Cl here. So these are the possibilities. It is 6th possibility. It is 7th possibility. It is 8th possibility. Is there any other possibility, sir? There is one more possibility. I have deliberately left it. You have to identify.
Sir, in first
In a
carbon
open
and
chain,
third carbon.
I can write Cls here. This is 9th possibility. So C4H8Cl2 can be 9. It is an integer type question seen in IIT Advanced. So this is a question of permutations and combination. It is more a mathematical problem. So I will not touch upon that. Simply they are asking simple questions. They are not asking very complicated questions. But I would say on record, C4H8Cl2 can have 9 isomers. How many, sir? 9. Should I write all those 9? C4H8Cl2. 1,1-dichloro.
Should we rejoin, Jay?
No, don't do that. That's enough. 1,1-dichloro. 2,2-dichloro, 1,2-dichloro, 1,3-dichloro, 1,4-dichloro, 2,3-dichloro. These are possible single chain compounds. 1, 2, 3, 4, 5, 6. Now I can introduce a branched chain, right? Here I will write. So this is a branched isobutane. Here I can put two Cls on first carbon. All the carbons in isobutane are identical. This and this and this are identical. All are primary. So whether I put two Cls here or here makes no difference. This is 7 carbon compound. Here I put one Cl, here I put one Cl. This is 8. In previous slide, how many I wrote, son? In this slide I wrote 6, right? 7, 8.